Hello, civil engineers. Welcome back to the lecture. So there is a code book by name IS 2502-1963. You can even download it for a Indian Standard Code Book, where it has given a formula. That means what it is trying to tell us. If you're using a stirrup or a lateral tie, something like this. Okay. So this is how it is. Then how do you find the cutting length? It is already mentioned. So this is a shape what we have, isn't it? So this is a shape what we have exactly. And it is telling us that this is a formula you need to apply directly. That means 2 into a plus e, where it is mentioned that this is a, where it is mentioned it is a. See, this is a, okay, and this is e. So 2 times a plus e plus 24 into d. If you apply this formula, you'll find the total cutting length. And one thing you observe, what he has shown here, that is very important. What he has shown from the center to center, isn't it? And how did I make you calculate? I made you this a, whatever he is mentioning, it is from this center to this center, that is center of your stirrup. Okay, this is a. And in the same way, this e what he has given, even that is also from center to center he has given. Okay, that is actually from center to center. Got it? So that is the reason we can directly use this formula now. That is 2 into a plus b, which we already done. We have got the top as how much did we get? 200 something, right? 262, 262 plus 112, 112. This hook length directly will add this formula, and that formula is 24 into d, and where d is the diameter of the bar. Got it? So this is what we are trying to do. Simple. So first I'll explain this. After that, I'll explain you one more method where few people follow that also. Okay. Now come to the cutting length. I'll do it here. Cutting length. This I'll remove it. Cutting length. I'll do it here. Plus, open the bracket. Okay. So add this 262 plus 112 plus 262 plus 112 plus 24 into d. You take it directly. 24 is a direct value which is there in the code book. So you write 24 into d. D is the diameter of the rebar. That is, we have taken 8 bar, isn't it? Yeah. If you want, you can open the bracket here so that it will do the correct, it will apply the correct board mass and hit the enter button. Finish. 940 I got. Here also I got 940. Got it? Now why no bend deduction has been done? This bend deduction is not done because this formula is directly given. So this formula is directly given. So here there is no bend deduction to be done. Now there is no bend deduction because this is from directly from the IS code book. So this 24D includes all the bend deduction in that. So that is why this is not required. You don't have to apply the bend deduction. Got it? Fine. Now, once this is done, next is finding the cutting length. This is 940 is in no, I want to find the cutting length in meter. Again, 940 divided by 1000 will give me 0.940 meter. Now total cutting length, so this 0.940 is the cutting length of one bar. How many such stirrups I have? 64 number of stirrups I have. And how many such number of columns I have? 1. Therefore total cutting length will be how much? Exactly 0.94 multiplied by 64 multiplied by 1 will give me the total cutting length, which comes out to be 60.16 meter. Now, since we are using a diameter bar and we have got a cutting length of 60.16, can you not find the weight of the bar? Obviously, you can find the weight of the bar will be 60.16 into the unit weight of 8 bar is 0.395. If I multiply that, no, I'll get it as 23.763 mm. Finish. That's how you're supposed to do. Now, you may have few doubts. We have seen people doing, instead of doing here, I took directly from the code book 24 into d. So what few people do is that they don't do 24 into d. So usually this stirrup length, whatever hook length what we have, no, this length, usually sometimes in the drawing it will be written in few of the drawing, and few people practice this to be minimum you have to take 75 minimum 75 both the side, or there's one formula which is 10 times the diameter of the bar. It should be minimum 75 Few people follow that. Few people use a formula of 10d. 10d. So 10d. Let us say I'm using a 8 bar. So 10 into 8 is 80 So I'll take 80 instead of take 80 Okay, getting my point. So that means this will be 80 one side hook, and the other side hook will be also 80 So 80 will be how much? 160 So people do that also. That is also right method. Otherwise, if I do 24 into 8, what will be the answer? 24d I took. No, I hope you're able to understand. Okay, there's no confusion here. So I'm getting 192 if I do this, and if I do this 80, it will be 160 So 30 difference will come. So no problem. whatever you practice on the site, that we are supposed to do. Okay. Now on your site, if you're using this method, that is 24 into D, your billing will be done according to this. If the client and the contractor and all agrees, no, we'll go with the minimum 75, 75. You can go with 75, 75. I mean, minimum 80, 80, 10D, 10D. Then you can go with this formula. But in no case, it should be less than 75 mm. So that is written in the code book. So in no case, this should be less than 75 mm. That I'll show you where it is. These are the different shape that is given based on it, how the BBS is to be done. Okay. So you can follow both things. I'll do for both of the thing. You can follow whichever you want. Yeah. See, here it is given. Forget about this, but not less than 75 mm. That hook length should not be less than 75 mm. Minimum it has to be 75, or you can take 10 times the diameter of the bar. If you don't want to do that, directly add 24D, and then no bend detection has to be done. Got it? No? Simple. If you want, I'll do that also now. So if you want to apply that formula, I'll do that also. What I'll do, 262 plus 112 plus 26 plus this one. Okay. After that, what we are supposed to do, plus 10 times the diameter of the bar I'll do. So 10 into how much? 10 into 8 mm plus 10 into 8 mm. Okay. Why 2 times? Because 2 hooks are there, no? So that is why. So if you want, you put this in bracket. Okay. So that it will get right answer. Got it? So it will come out to be 908 mm. Okay. Of course, it will come 908 mm because it will fall short. This is one way. There are people. Now there are also people, those who add the bend detection also. That means again, open bracket, what you'll do, 262 plus 112 plus 262 plus 112, bracket close, plus hook length will be 10 times the diameter, 10, 10, I'll do 20 times. Okay, 20 into diameter. Diameter is 8. Okay, then bend detection they are going to do. Why? They say here there is a 90-degree bend, 1, 2, and 3 90-degree bend. And this is 135-degree bend. Getting my point? So there are people, those who do that also, minus 3 90-degree bend. 190 degrees 2D. So 3 90-degree means this is 90-degree bend. 1. This is second. This is third. So 3 2s are 6. So 6 into D. 6 into 8. Okay. I'll put that. Okay. This one. Minus this bend, what we have now, this bend, this is a 135-degree bend. It is bending in 135. So for 135, I told you that you should take 3D. If it is 45, it is 1D. If it is 90 degree, it is 2D. If it is 135 degree, it is 3D. So how many hooks are there? This is 135 degree, 135. Two hooks, 135. So if 135, if 135 degree is 3D, 3D plus 3D, 6D. So minus again, open bracket, 6 into D, diameter is again 8. You're getting my point, no? Close the bracket. So all of you are correct. Now, whatever you have on your side, you can follow. If you're following this, like I explained, 24 into D, this will be on cutting length. If you're applying the hook length, you're taking minimum 10D, 10D, you can follow this. There are people, those who apply the 10D and also do the bend deduction, then you follow this. Now, whatever you follow here, the same billing will happen. That's the final conclusion. So none of you are wrong. So you may, before taking my lecture, you might have seen someone doing this kind of method. Before taking my lecture, you might have seen few people on YouTube, or maybe your seniors, or maybe anywhere you might have seen people doing. So I've taken all the 3 cases. Okay. So always people refer this IS 456 method because this is directly given in Indian Standard Code Book. Okay, this is that code book where it has to be 24 into D. So this is a perfect method. And if somebody asks you for the logic, you have the proof ready with you that this is what the code says. And based on that, I have gone wrong. So if you want to prove me wrong, make this whatever code is there, you prove this wrong, then my answer will be wrong, because 2 into A plus E plus 24 into D. So that is why first method I have gone with that only. 940 is the right answer. This is also correct. This is also correct. So it's like 2 different school of thoughts. And I've given a lot of explanation for that, where when the load coming on a beam is, let us say, 11.5 kilonewton, some structure engineers consider it to be 12 kilonewton based on his experience. Some they say that, oh, okay, 11.5 only will come. He'll take 11.5 and design his beam. There are few people who say practically 11.5 doesn't come. We'll take it as 11. So all 3 people are correct, right? The same thing. But ultimately, whatever you do here, same has to be executed. If you're doing this bend deduction, if you're doing 24 into D, 24 into D, then practically cut your bar according to that and do the execution. If you're doing 908, then you do the same thing on the side. If you're doing this one, bend deduction, do the same thing on the side and get the same thing. And when the contractor has to bring the same thing for the billing, that's how it is. Okay, fine. So I've explained you all the three methods. Now it's up to you to decide whichever you want to do. Fine. Now the last part what we have is a links one. So this link one, what is this link? I'll explain you. So for this, I want to show you some images. Yeah. Now in our drawing, we have two kind of lateral tests. One is called as mastering, which we have done completely. Then there is one more guy. Then there is one more lateral test, which goes something like this. Okay, this one. It will be like this, coming like this and coming like this. So we need to find the cutting length for this also. So practically how it looks, I'm showing you an image for that. Already basic course, if you have taken, I've covered all these things there. I've explained you how these things is designed and all those things. So if you see here, see in center portion here, here you can see that a kind of a hook is given. So in this way, practically they give. So in one column, if your column is huge and all based on the requirement, because based, see, this is a criteria to decide all those things. If you go to SP34 code book, all these things are given. When you have to use that single tie, when you have to use two ties, when you have to go with a group of three ties, everything is there. That was covered in my basic class. Okay, that is site engineer construction methodology class. Okay, now you see here, here also, this is one hook. Okay, it has gone inside, you cannot see it. Same thing here. Okay, you getting my point now? This, so this cutting length I'm supposed to find now. Same thing here also, it is there. This one, fine. Now how do you find this cutting length? Very simple. This cutting length, what you're supposed to do, whatever you get here, no, same thing you have to write here. Why? Because wherever is this breadth side, this one, okay, same thing is this one. Okay, so whatever is this one, same thing will be this one, for a very same reason. If I take the column dimension, so our column was something like this, isn't it? So this is how our column, this is how our column was. Okay, and yeah, this is how our column was, and this lateral ties will be placed in this way. Okay, it will be placed in this way, in this way. Okay, and then I think one mistake I've done, I'll change that mistake, not an issue. Then this will come like this. Okay, if that is the case and small mistake has happened, okay, then what will happen, then whatever is this length, no, that I need to take. That means it's 112, not 262, it has to be 112. No problem, I'll change it. This one it should come. Yeah, now it's correct. So okay, actually I should have drawn it in this way, it will look like this. Okay, so it will be placed. Okay, I'll show you here. Practically it will be placed like this. Okay, practically it will be placed like this. So whatever is this length, no, whatever length we got, that is 112. This also will be 112. So that is why I have written 112 here. Simple. Got the idea, no? Why, how it is placed? Yeah. Next, I want to find only this hook length and this hook length. If I add to this 112, I'll get the total cutting length. Number, same number. Whatever number you got here, same number. Because this rings, whatever you place, no, if you're putting in the group, if there is three groups, like one master ring, then this one, it will remain same. Okay, so you just have to interlink this, and spacing and all, everything will remain same. So I've written here link for C1. You call this as link. So 8 diameter was 8. Here also I've written 8. So spacing was 200. Here also it is 200. Number of we got 64. Same thing I've written here. So I've interlinked all these things. Okay. So the moment you get this answer you'll get. Only the cutting length will change. And that too, you need to add this hook and this hook. Whereas this part is already added. This part, whatever you have, no, this and this is same. Got it? Fine. So now, how do you find this hook? This one and this one. So this and this hook, where do you get the answer? So for that, the answer is you need to come here. Yeah. Yeah. So this one, this length, how do you find? I'm asking you this length. So this length, it is bent in 135 degree. So from what is the length of this? So again, for that, we have to go back to the code book. So in the code book, it is mentioned how much you are supposed to take. So if I come here to the code book, so it is written here. Okay, so this is how it is. This is that particular shape. Okay, see, this is L what we take, and this is H. This entire thing we consider it to be H, and this entire thing we consider to be H. This is what we are supposed to find. So it is given here directly. Yeah, how much are taken? 13D. Okay. Yeah, so it is given here, hook allowance. Okay, so what they have written? So they have written hook allowance is taken as 9D, 11D, 13D, and 17D for K values 2, 3, 4, and 6 respectively. So what do you mean by this? It is written hook allowance is taken as 9D, 11D, 13D, and 17D for the K values 2, 3, 4, and 6 respectively. Now what is this 2, 3, 4? So according to the code book, according to this code book, they have classified. If your K value is 2, that means it is in case of mild steel. If your K value is 3, it is in case of medium tensile steel. And if your K value is 4, it is for the cold twisted bar or HYSD bar. That means I'll explain you here. See, your different categories here. This is your mild steel. Okay. Then you have medium tensile. This is your 3. And this is your 4. This is your K value is 4. So that means now whatever bar we are using in the market, they all are CT, that is cold twisted deform bar. CT, cold twisted CT, right here. Cold twisted deform bar. We call this as CTD bar, okay? Or you can call it as HYSD bar. So that falls under this category, that is cold work steel bar, conforming to IS 1786. So if you are using that bar, in that case, your K value is 4. And for the K value 4, you have to take 13D. See, again, I'll tell you, I'll write here if you don't understand. So first I'll make 2 columns. Okay, let me make 2 columns. Okay, and I'll explain you. It's very simple. Just the fundamentals part I'm trying to make you understand. That's it. Only once if you understand, you can carry on with that. This is for 1K value, second K value, third K value. Then we'll go for the last one. Okay, fine. So I'll write here, if my K value, yeah, if my K value is 2, this is for K value 2, this is for K value 3, this is for K value 4, and this is for K value 6. Okay, I'll write here K. This is for K, and this is for hook allowance. Okay. Okay, fine. This I'll write hook H. So it is written 9D. So it is 9D. Then it is 11D. 11D. Then it is 13D. And this is 17D. Okay. Now you understood. See, I'll explain you. What does it imply? Right now, we are just concerned on this cold work because that is a bar what we usually use in the structure nowadays. It is called a CTD bar or HYSD bar. So if you're using a HYSD bar, it says that it falls under the category 4. So this is my category 4. So from where did I come to know? It is written here, 4. See here, 4 in the case of cold work steel firm conforming to IS 1786. This much is clear. So that is falling under 4. Now, if it is falling under 4, then it is telling that you have to, where is 4 my? So if my K value is 4, what I need to take? H value will be 13D. So that hook length, what I'm supposed to take, this hook, this one, what I'm supposed to take is 13D. That means this is 13D on the left side. This will be 13D and this is 13D. This much is clear. That's it. This is what I wanted to tell. And where was it written? It was written here. But again, this should be minimum 75 mm. Minimum 75 mm. So it is written minimum 75 mm. So directly they have given what is the diameter of a bar we are using now? 8 mm bar. So directly these people have directly given what should be the minimum length you are supposed to use for 8 mm. So I'm using for 8 mm. Okay, this is 8 mm. And under the 8 mm, look what is the answer I'm getting. This is 8 mm. I'll make a different color. Yeah. So I'm using a 8 mm bar. I mean, wait. Yeah. I'm using, yeah. I'm using a 8 mm bar. And for 8 mm bar, what is that mentioned? 100 and 105. Okay. How did it come to 105? Very simple. What is 13? 13D. No, I told 13D. So 13 into 8. You do what is 13 into 8? It is 104. 13 into 8 is 104. That's it. So 104, and the code is saying us to take 105 mm. So this should be 105 and this should be 105. Simple. And if it is 10 mm, obviously it will be 130 because 13 into 10 is 130, but it's mentioned 130. If you're using a 12 diameter bar, you have to take 155 because 13 into 12, right? Yeah, 13 into 12 is this one. That is how the answers are coming here. Simple. So now don't scratch your head anything. Just remember you have to take 13D. And from where did that 13D came? I gave all the explanation. Got it? Nothing. Go back to the Excel sheet. And here, come here. So spacing will remain same. Number of bar will remain same. You'll see here what I have done. Okay, this one. 104. Why, from where did it come? I written here. 13 into D. What is D? D is 8 mm. So how much I got? 104, 104. What did the code recommend? The code recommended us to take 105 minimum. Where is that? 8 mm. It was 105. 105, we have taken 104. If you want to take 104, you directly write 105 also here. No problem. Okay. So 104, 104 and 112. So the total cutting length will be again same. 104 plus 112 plus 104. Again, no bend deduction because directly from the IS code we have taken that value. So no bend deduction to be done. Okay, fine. That's it. Now cutting length will be 320. You divide this by 1000, 0.32. Now this is a cutting length of 1 bar. This 1 bar cutting length I have got now. So total cutting length will be 1 bar cutting length multiplied by number of bar into number of member will give me the total cutting length. And weight, since it's a 8 mm bar, it has to come in the 8 dia column. So 20.48 into 0.395 will give me the total weight of the bar. Finished. That's it. Your bar bending schedule for one column I've explained. So it took so long, but it is very simple. You have understood the concept. Fine. Now, if you ask me, tell me the total steel, just have to add. I mean, I'll add it later when I finish everything. But for at least for C1 column, if somebody asks you how much steel is required, just write here. So what we'll do is we'll make a column here only. I'll drag this, I'll merge it and just add everything. Plus this one, lateral ties, rings, plus 23. Okay. Plus this one, plus, where is that last? Yeah, 196. This one, no? Correct. 196, fine. Enter. So almost 227 kg of a steel is required for C1 column. If I want to do C1 column, main bar, longitude, lateral ties, first lateral ties, and the links, I require 227 kg of a steel is required. That's it. So this was a complete BBS for the column. Now after this, I'll teach you how to prepare the Excel sheet in the next lecture. Then rest all things, I'll explain you overall how it has to be done. You understood the concept. Rest things, I'll explain you for everything, but it remains the same. Nothing changes. You just have to copy paste. Like you'll copy again. Next from here, you copy everything like we did in the footing. No, same thing. Copy and then Control C and paste it. And then come to the drawing, come to this estimation drawing. Now next we'll consider C8, C12 and C25 columns. So 3 columns are there. In that case, what you will do, you just have to mention 3 times. Yeah. So you see, like I mentioned here, C8, C12, C25 on F2 footing and 3 numbers are there. So here I've done an input of 3. That's it. Got it? No? So in this way, you have to finish the complete BBS for the G+2 building. What I for that drawing is given here. You have to look into the drawing, and based on that, this drawing I've done modification. Okay, just to make our calculation easy, and later we'll take the difficult part. Now it's easy. Fine, good. So in the next lecture, I'll teach you Excel sheet, and then we'll finish everything. And then one lecture I'll take where I'll explain you all these things in a even better way. Okay. So all your doubts I'll solve. In spite of this, if you still have doubts, you can always get back to this number 9953779047. Okay. Plus one you can add here. And else, if you don't want to get on the WhatsApp, you can get on the mail. Akshay Kamath, AKSH AYKAMATS73 @gmail.com. If you mail, if you have any queries, if you're not able to understand anything, I'll get back. You can contact me here and I'll solve your doubts. So we'll see you back in the next lecture. Thank you.